Hi, everybody. This is the first lesson for this Math 1A Unit 1 class. This would be the lesson from Wednesday, September 8th. Wednesday the 8th. So, the first day of lessons. So, if you missed this day, you'll want to be taking notes during this. And then afterwards, you're going to take the mastery test in Edmentum. So this lesson is called Expressions, and it is kind of a mixed bag, a big review lesson from lots of other topics that you would have seen before. So get some paper and pencil out, take notes on all the definitions, all the examples, and get a calculator ready because you'll probably need that as well to do some quick calculations. Use your phone or the Google calculator. Here's all the topics we're going to go over here. Some initial definitions to start on definitions of expressions, then order of operations, then simplifying expressions, evaluating expressions, a little different, adding and subtracting fractions, combining like terms, absolute value, and then mixed numbers. So for our definitions, let's start with this. We want to define all the parts of an expression. What is an expression? What are all the parts? So let's start with this as our example, 5x plus 1. So here's our expression. This whole thing is the expression, 5x plus 1. Now this is made up of different terms being added or subtracted. So this has two terms. 5x is a term, and then 1 is a term. So anything that's being added or subtracted to each other are the different parts of the expression. And then they have their own special names as well and distinctions. So let's start with the 5x. So these are both factors because they're being multiplied to each other. So anytime you've got things being multiplied to each other, you could call the individual parts factors. So 5 is a factor, x is a factor. 1 isn't really a factor. It's not being multiplied to anything else. It's just hanging out by itself, being added to the other term. Another important name we need is a constant. A constant is something like a whole number. It could be a fraction. It's anything without a variable or an x or a y attached. So 1 in this case is our constant. And I'll add a little to that. It's any whole number or fraction or decimal without an x or y on it. Or I guess I should say it's not a factor. There's no other thing being multiplied to it. Or any variable. And now I should back up and talk about what is a variable. Well, a variable is like our x right here. It's called that because it varies. We don't know what the number is that goes in place of that x. It stands for a number. It could be -2, it could be 112, it could be 5,000, or it could be 0.5. We don't know. Um, we could plug anything we want in for that x, and then it would change the whole expression to something unique. So it varies, and that's why it's called a variable. And then the last term I want you to know is coefficient, and this 5 is a coefficient. Coefficient. There we go. So the beginning of that word, the prefix is co, and that means to that means together or with others, just like coexist or co-worker. Uh, it means that it's with something else. And see how the 5 is with that variable x? Coefficients are always a number that's being multiplied to a variable. Number being multiplied to a variable. Okay. So those are the different parts of an expression. And you could say that an expression is um, just a collection of terms being added or subtracted. And then we could further define those terms based on what they are. Are they constants? Are they variables? Are there coefficients with those variables? That kind of thing. All right, here's simplifying expressions. So whenever you hear the math teacher say simplify the expression or simplify this problem, what we mean is this in the box. It's to do all the adding, all the multiplying, all the subtracting or dividing. So there's nothing left to do. We want to kind of make this big looking expression look smaller at the end. So let's simplify this expression and see what it comes to. So I'm going to start inside the parentheses. The parentheses are there as like a container to kind of group things together. So whenever you see parentheses, you should always start with those first. 4 squared, or 4 to the second power, that means 4 times 4, just as a reminder. So that's 4 times 4, that's 16 plus 3. And I'm going to carry down all the other stuff that I haven't done yet. All right, 16 plus 3 is 19. Now, what we have here is 5 times 19 minus 6 times 2. You're going to see multiplication written out both ways, just like this. We don't really use this symbol anymore for multiplication up here at the top. When we first learned multiplication, it looks like that, like an X, right? But we're not going to use that anymore, basically from this point forward. Now we're going to start using the little dot like this, or you could have things next to each other with parentheses. That means multiply. So let's do those multiplications. 5 times 19, 95.
All right. How much do you care about outlooks?
Minus 6 times 2, which is 12. And then this will be 83. So this expression that we started with up at the top in black, it all simplified to this answer. It's really just equal to 83. Okay, now order of operations. So this is the best way to always do your simplifying of an expression. The order of operations is in this box here. Start at the top and work down as you go. So if there's parentheses in the problem, always start with that. If there's any exponents, do those next, and then do any multiplying or dividing, and then end with your adding and subtracting. Now, like if there's adding or subtracting in a parentheses, that kind of takes precedent. Okay, so you're gonna, whatever's in the parentheses, do that first if you can, even if that's something that's later in the list. But one way that people remember this list is this word. It's a made-up word, PEMDAS. It's the first letter of all the operations. PEMDAS. So you might hear me say that again throughout the year. This is what I'm referring to. All right, so let's simplify this expression using our order of operations. So I want to start with parentheses, so that's negative 6 plus 2. So I'm going to bring down all the stuff that's not in those parentheses. Okay, negative 6 plus 2, that'll be negative 4. Now, there's no exponents here, so let's do any multiplying that we see. So 2 times negative 4, that gives us a negative 8. And in the bottom, we've got 4 times 5, so that's a 20 minus 15. All right, on the top, we've got 10 added to negative 8. So just as a side note, 10 plus negative 8. Well, this is the same thing as saying 10 minus 8. And it's the same thing as saying negative 8 plus 10. And these are all the same idea. Basically, if you've got a positive number and a negative number, they're going to kind of battle with each other. And who's ever bigger, that's the one that will have leftover when they're done adding or subtracting. So 10's bigger than 8, right? So there'll be more positive than negative left over. So that's going to be a positive 2. 20 minus 15 is 5. So we get this fraction 2/5 as our answer. Simplified from how it started above. Okay, combining like terms. Like terms, this is the idea that we only can add and subtract numbers with matching variables. So if you have different terms in your problem, in your expression, some with y's, some with x's, some with a's, b's, or c's, you can only add the like terms or subtract the like terms together. So when I look at this problem here, we have 3x plus 2y minus 5y plus 11x. Which ones are like terms? Which ones match? I scanned through and I see that we've got an x number and later another x number. Those can add or subtract together. So this says, let's just focus on the x's. We'll come back to the y's. So 3x's plus 11x's. It's like saying 3 plus 11. 14 x's. Don't forget to bring that x with it, with your answer. And now for the y's. I scan through, I see 2y numbers. So 2y's minus 5y's, negative 3y's left over. Remember what I said last time? Here's a battle going on between the 2 and the 5. Different signs, so that's why it's a struggle. It's a battle. Who's bigger? Well, the 5 is bigger, so there's going to be leftover negative because the 5 was negative, right? So that's how I know this is going to be negative 3y. I can't do any more back to our answer because x and y are not like terms. So we're done. Oh, there's another one. Okay, so example 5 below there. Okay, so this time there's really no like terms that can go together right now. I see an x and I see a negative 5x, but this one's in a parentheses, this one isn't. We can't really combine those yet. So we have to start with our multiplying. I'd like to start with parentheses first, remember? But I can't add x and 2. So we kind of say, okay, we check the parentheses, we can't do it. So we go down PEMDAS and we end up doing our multiplication. So 5 times x and 5 times 2. We're going to multiply that 5 to everything in the parentheses. So 5x, 5 times 2 is plus 10, and then we have to bring down that minus 5x. Okay, now look for your like terms. Here's an x number and another x number. 5 minus 5, 0. 0x. Now, because it's a 0 and not any other number, remember 0 times anything is just 0. So this whole thing goes away, and our actual final answer is just good old 10. So again, we started with a complicated looking expression up here, and we simplified it to a smaller version. Okay, evaluating expressions. So evaluating, if you ever see this word, what this means is they're going to give us some value to plug in for the variables. So let's look at my box. Evaluating means simplify after plugging in a certain value for the variables. So really evaluate just means simplify like we've been doing, but we have to start by plugging in some value given for the variables. Okay, now here's the rest of our actual example. It says evaluate the expression when r is equal to 3 and s is equal to 6. So if you look at the problem above, you can't really do anything with it. There's no like terms. There's an r number, an s number, and a plain old 2. But once we plug in our values for r and s, that'll change. Okay, so it says r is equal to 3, so I'm going to switch out 3 for the r, and I'm going to switch out 6 for the s, like that. Okay, do the multiplying. 5 times 3, 6 times 4, plus 2, didn't use him yet. And now add everything together. Looks like it comes out to 41. So this was equal to 41 when r is 3 and s is 6. So this is us evaluating the expression when r is 3 and s is 6. All right, absolute value. So I think you've all seen this before, but let's talk about it and let's try a problem. Absolute value means make the number inside positive, but it's maybe I should have add to this a little bit. So absolute value, like this, these two bars, this is a symbol telling us to find the distance of whatever's inside here to 0. So for instance, this is a side example. Pretend this was our problem. Absolute value of 5. So the question is, how far is 5 from 0? How many units? How many spaces? It's 5. How far is negative 5 from 0? It's also 5. It's 5 spaces away. Remember, distance can never be negative. So whenever you have a number, a value inside absolute value bars, that's when we make the number positive. Look at both of those outcomes. Both those answers are positive 5, right? Even though they weren't both positive 5 starting. The negative and the positive both turn positive. So if we look back to our problem, we're not just going to make everything in there positive. First, we have to combine it all together. So this problem says evaluate the expression when x is equal to 12. So let's start by plugging in 12 in for x. Okay, now you can kind of clean that up inside the absolute value bars. Negative 12 plus 5. Who's bigger? 12's bigger. So there's going to be leftover negative inside there. And how much? What's the difference between 12 and 5? It's 7. So it looks like negative 12 plus 5 is negative 7. Okay, now we are ready to make the number positive. So the absolute value of of negative 7 is 7, right? And then it's going to be multiplied to 4. And there's our answer. All right, now, fractions. I know that fractions can be a worry or a concern, so I want to go over those with you, and we're going to continue working on these together throughout the whole year. So here's two problems. Let's just look at the top one for now. We have 4/3 plus 5/3. So here's some tips on the right. To add or subtract fractions, they must have the same denominator. If they don't already have the same denominator, we must fix that. So example 8, look at those two Those two numbers, do they have the same denominator? Just a reminder, denominator means the bottom number. So yes, these do have the same denominator. This says 4/3 plus 5/3 is how many thirds? Well, we're just adding those two tops. 4 plus 5, that's 9/3. And if we we want to reduce or simplify our fractions. So 9 divided by 3, that actually does come out clean to a whole number. That comes out to the number 3. So 4/3 plus 5/3 is equal to 3. Now, example 9. I can't add these because look at those denominators, 7 and 4. They don't match. So I said in my box, if they don't already match, then we must fix that. We must make them have the same denominator. So here's how we're going to deal with this. Remember that, think back to early rules you learned in math. Anything divided by itself is always 1. So, for example, 10 divided by 10 is 1. And it works with variables too. X divided by x, because those are the same number, is equal to 1. So anything divided by itself is 1. So with that spirit in mind, I'm going to multiply the 2/7 by 4/4, and I'm going to multiply the 1/4 by 7/7. I can do this because 4/4 is just a 1, and 7/7 is just a 1. And I'm multiplying my original problem by 1, so no big deal. We're allowed to do that. Remember, another rule early in math is that multiplying 1 to any number is that same number. So now we can change what these look like. So 4 times 2 is 8. 4 times 7 is 28. 1 times 7 is 7. And 4 times 7 is 28. So notice that on the bottoms, we had 4 times 7, 4 times 7. And that was by design. We purposely just manipulated this expression so that they had matching variables, or matching denominators. And now we can add them like we did example 8 above. So 8 plus 7 is 15. 28. Check to see if you can reduce it. In this case, we can't. 15 can be divided by 3 and 5. 28 can be divided by 4 and 7. And that's it. Or in 2. But we can't divide the same number from top and bottom, so we're done. All right, now to talk about mixed numbers. Sometimes in Edmentum, they give you a problem to do, and maybe you get a fraction answer. But maybe the answers they give you as choices are mixed numbers or decimals. And we need to be able to kind of go back and forth between all these different versions of the same number. So here's a fraction, 70/8. So how do we turn this into a mixed number? We're going to divide 70 divided by 8 on paper the old-fashioned way. Okay, so 8, does it go into just plain 7? No, it's too big, right? So 8, does it go into 70? It does, but I'm not sure how many times. So let's do a little bit of trial and error to see how many 8s go into 70. 8 times 5 is 40. Okay, we still got some space, so let's try a higher number. 8 times 6 is 48. 8 times 7, I think, is 56. 8 times 8 is 64. That's pretty close. So we're trying to get as close to 70 as we can without going over. 8 times 9. 72. So that one we don't want to use because that's too big. So we're going to do 8 because 8 times 8 is 64. Okay, so 8 goes into 78 times. Now you multiply 8 times 8. That's 64. You put it below. Subtract. And we get this remainder of 6. So to write it as a mixed number, we take this number on top, and we take our remainder, put it right here, over the original number we were dividing with, 8. So 78 is equal to 8 and 6/8. And we can clean up our answer a little bit more because 6 and 8 are both even. So we can divide the top and the bottom by 2. And let's see what we get. 8 and 3/4. That's better. And that's a mixed number, a whole number with the fraction. So sometimes the answers might be in this form. So we have to be able to find this version. Think about it this way. You wouldn't measure with a ruler 78, right? That would be really hard. But you could measure out 8 inches and 3/4, 8 and 3/4. That's a lot easier than 70/8 of an inch. But they're equal to each other. This here that we started with is the same mathematically as this.
Actually, go ahead and use that one.
Okay, I have another example, and I covered it up. 45/10. Let's do it right here. We'll do another mixed number. 45/10. So let's find this mixed number. Okay, 10 goes into 45 4 times. 4 times 10 is 40. Our remainder is 5. So 4 and 5/10. And then we can reduce this because 5 and 10 are both divisible by 5. So it comes out to 4.5. All right. All right, and that does conclude the first day. There was no homework for Wednesday, the 8th. But I did take roll of everyone's notes. So what I'd like for you to do, if you're watching this video for the first time and haven't seen this lesson with me before on Wednesday, September 8th, then what I'd like you to do is to send me a picture of your notes, okay, of these 12 examples and any definitions that you took. That'll count for your participation grade for the very first day of class. There'll be a video for the second day, which is where we picked up right here. And after this lesson, Expressions Day 2, you should go to the Mastery Test in Edmentum. It's in Unit 1. It's called Expressions. And I want you to take your Mastery Test as your homework. It'll be due Monday when we come back on the 13th, September 13th. Have a great day and a great weekend, and I will see you on Monday.